Okay, you can hear me. Okay, so I'm Kaifler. Or first of all, as you might know me from Discord or GitHub or I don't know, whatever. And I will talk to you about supporting more image formats, how you can, with some new API changes, do it easier than before and a bit more. Okay, so I'll start with the new Pixmap API. So you might know normal image formats. They do compression and all that fancy stuff, which is annoying if you want to output to that format. And so there's these things called Pixmaps. They are pretty simple. Everyone can basically use them if they can output bytes. For example, this is just a simple one. Zeros are black and FFs, like the largest number, are whites, and they would output this little image here. And you can do the same thing with actual colors. So here's red, green, blue, and of course, if you have only red and zero blue, you get a red color, as you can see in red. That's for all of those. And you can mix those colors as you usually would. So here's a bit more blue than in the center color, for example. I mean, you can see it. It's pretty obvious. So those are Pixmaps. They would allow you to visualize graphics without trying to encode images in PNG, JPEG, or whatever. And but also and that also means that you can just not use the inbuilt types functions like rect, circle, square, and whatever, which can accumulate to be quite slow if you want to visualize a custom diagram or whatever. So, and then the primary content of this talk is like for using it to generate actual images from formats that Typst itself doesn't support for some reasons. One of those reasons would be that the Typst binary would bloat to huge proportions if you supported like every single format that's out there in existence, JPEG XL, AVIF, or WebP. There have been a number of issues on that. And of course, adding that API makes plugins that output images in some form much easier to write, because you don't have to include a PNG encoder or write in reserve for some reason. And so this API isn't finished. There will be some feedback from some people here. I don't like it particularly much, but it works. It exists. So Pixmaps are just flat maps of bytes. They're just this. They don't contain any metadata like width, height, ICC profiles, or whatever that is. So you just have to provide them bytes, which are the raw image file data, and separately also the width and the height of the image, which is necessary to actually make sense of what it contains, because otherwise it's just a long string of colors. You usually want 2D images. And then you have to provide the format of that Pixmap, in this case RGB8, so 8 bits per component, red, green, and blue, and no an alpha channel, like the transparency channel. And also another feature of the workEdit is adding a scaling attribute, which allows you to specify whether you want those images like pixelated, as seen here, or smooth and mushed together, which is good for like photographs, but for pixel art you usually want pixelated images. You can also just let the document viewer decide it for you, which may or may not look ugly. So that's that. Okay, so the primary content of this talk is actually writing a custom plugin. We are using the WebAssembly minimal protocol for that. It's made by Asmara Sharp, I think, and it makes the like this grading makes it a bit easier than it would be when doing it manually. So you import it, add it to your cargo terminal, and run this macro, and then you can define a function annotated with the WebAssembly func attribute here, and the name will be the one you call from Typst. And then there's also the input parameters, and these have to be U8 slices, like so just bytes, nothing more. You can't do strings, you can't do integers, you have to decode those manually from those slices, which is annoying, but it's the state right now. And then you can return some bytes as well. The Typst side from it all will have to convert those bytes to useful data structure as well. So the decoding part in this case is just checking whether it's UTF-8, like the primary text format, and then formatting the cell, whatever the name is, and returning bytes. Okay, so that's a little overview of how that format, that wasn't minimal protocol works. So now images. We use ImageCrate for that. It supports a lot of image formats. All the ones I mentioned besides JPEG XL, for example. You first have to get some gigabytes in a readable map form, and for that you use the cursor type. It is just a wrapper that makes the byte slice implement read, not that important. And then you create a new image reader with that cursor, let it guess the format, and then decode the image. You want a single shared type of image format in the end, because the image.decode function actually needs RGB-A8 or whatever, like one specific one, and can't really guess it. So it also means that 16-bit images will be compressed to 8, but it's the case anyway, as it is right now. So we call it into RGB-A8, and then use srow to convert, to just get those bytes from the image. Now we need to convert this whole thing to a structure that can be read by the Typst side. We therefore define a new vector that contains the output bytes. We put the riff in there as little endian, and then the raw image bytes. We don't need a height because we can just calculate the height from the length of the image and the width. So here's the Typst site. Oh, okay. Okay. I need to figure. Okay. So we call a plugin and render function from it, and then we slice the width up from it. We get the pixel data and get a height by dividing the pixel data by the width and by 4 because each pixel is 4 bytes wide because it's red, green, blue, and alpha, which are each 8 bytes large. And then we call the image.decode function with the data, the pixel width, the height, and so that, hey, this is RGB A8. And this function here also takes some arguments which the user can provide, like the display width or whatever they like. And here's an example how you would call it a function. You need to use the Greek function definitely because paths, path types or resource types or whatever don't exist yet. And you get an image. Okay, and then there's current state of the pull request and what I have worked on. These are the supported image formats, but from what I manually wrote. And you can see, yeah, there's PDF. I integrated Vue PDF as a plugin, and it renders PDF to an image and kind of output this into your document. It's of course doesn't support scaling, like you will, if you zoom in, you will get pixels, but PDFs. Then JPEGs, that's a different crate from the image crate. It's done using JXL oxide. And it's a really nice image format. It works. And of course, all those other formats were key. In particular, that one was often requested. But also PNG, if you ever wanted to do that. Okay, and then there's also support for changing the image scaling algorithms. I already talked about it, autofilm or whatever the viewer does, which is quite different depending on viewer. Pixelated, well, it should be clear, and smooth, for example, isn't PDF-A compliant, so it will be disabled there, but normal PDFs are supported just fine. And things that I still have to do, which are allowing pixmaps to be compressed lostly, because currently they are just exported as PNG, for example, not JPEG, which is a bit, it's not great for photos and will load the document size a lot. Then allowing Typst colors as input and not just bytes would be nice, but I don't know. ALIF wasn't on a list. That's because the image crate uses a certain library which is not WebAssembly compatible. It can be made compatible, but I just haven't done that yet. And then, of course, the API needs to be decided upon. Pull requests and packages also need to be published. Okay, that's it.
Any questions?
Any questions there? Yes?
What is the scaling support in the SVG format?
That also works. SVG 2 has the image rendering parameter, which sucks, and SVG 2 doesn't exist yet.
Yeah.
For, I don't know, 15 years or something. But SVG also supports CSS, and you can use CSS as image rendering attribute to change that. So that works. The decent browsers. Yep.
I'm curious because I didn't really investigate UPDF yet because it's anyway not license compatible with Typst for the compiler. But my latest state on this by Vinaigrette was that it somehow doesn't work on WASM, something with exceptions. Did not run into any troubles there.
I ran into a lot of troubles there. There's an easy trick. You just have to fork the even scripting compiler to not generate like things like exceptions or certain worthy function calls.
I see.
Okay, and get the last nice round of applause talking in scripting.
But it works. You will get error messages that don't make sense though if you put anything other than a PDF in there. So have fun debugging that.